Alright, let's get started with this problem, 7.44 from the Sadiku textbook. The switch has been in position A for a long time. At t equals 0, it moves to position B. Calculate I of t for all t greater than 0. We have a circuit with a switch. At time equals 0, it moves to the point B. So it goes this way, following the arrow. We have one capacitor in this circuit. In other problems, you may have an inductor. The problem is asking for the current through the capacitor. We know that no matter what quantity the problem is asking for, we need to find the voltage across the capacitor first. If this were an inductor problem, we would need to find current through the inductor. If we try to find current through the capacitor, or voltage, say from here to here, or current through here, if we were to try to find any other value or quantity in this circuit prior to finding voltage across the capacitor, we would get stuck. We would not be able to do that. No matter what the problem statement is asking for as the end goal, we need to find voltage across the capacitor first. So voltage across the capacitor, we write Vc of t. It's a function of time. The C designates capacitor. So I have a formula for voltage across the capacitor. It equals some constant A times e to the negative t over tau, a time constant, plus voltage across the capacitor in steady state. This also means voltage across the capacitor at time equals infinity. This is my solution for voltage across the capacitor. I have missing values that I need to find. I need to find what this constant A is, I need to find what tau is, and I need to find what this voltage at steady state is. So I'm going to start with finding tau. For tau, I know that for a capacitor, tau equals RC. The C is the capacitance, and that's given, 2 farads. The R means R equivalent, or R Thevenin, of circuit. How do we find R Thevenin of a circuit with independent sources and resistors? We need to remove independent sources, and then we need to combine resistors. So let's get started with that. I'm going to draw out my circuit, removing the independent sources. To remove a voltage source, I short it. So shorting the 60 volt source, shorting the 24 volt source. And now I come to my switch. What do I do about my switch? Tau is found when t is greater than 0. So I draw the circuit when time is greater than 0. So where will the switch be at time greater than 0? Well, at 0, the switch goes to B. So when the time is greater than 0, it will still be at B. When I get to my capacitor, I need to realize this is the location where I'm trying to find my equivalent resistance from. So to do that, I draw an arrow just to guide myself and show where I am trying to see the equivalent resistance from. This is why drawing eyes can help. You're trying to find the equivalent resistance as seen by the capacitor's location. If you don't specifically designate this and draw where you're looking from, then your nodes and terminals can get mixed up and you can end up with the wrong answer. So this is important. I see that this is dead wire, and I'm left with a 3 ohm resistor and a 6 ohm resistor. I'm going to circle my nodes, and remember, a node is all the free space along the wire until you run into a component. So I have 2 nodes. I notice the definition of parallel resistors is that they are connected across the same set of nodes. So 6 ohm resistor has one end in this node and another end in this node. The 3 ohm resistor shares those same nodes. So that means 6 is in parallel with 3. Which would give me 18 over 9, which would equal 2 ohms. So R equivalent as seen by the capacitor is equal to 2 ohms. So now I can find tau. Tau equals 2 ohms times 2 farads equals 4. One quantity done. Now I need to find this A somehow. And to get A, I can't find it directly yet, but what I can do is find an initial condition. So find the voltage across the capacitor at time equals 0. Specifically, we're looking at time equals 0 minus. If I were to find the voltage at time equals 0 plus, then again I would get stuck. I would not be able to do that. There is theory behind that, but I'm not going to get into that right now. So just for now, know that you need to find the voltage across the capacitor at 0 minus. What does 0 minus mean? It means, if you remember your limit terminology from Calc 1, it means right before time equals 0. So if this is time and this is 0, at 0, the switch moves to position B. Anything greater than 0 is t greater than 0. Right after 0 is 0 plus, and right before 0 is 0 minus. So we're finding the voltage across the capacitor right before the switch moves to B. So I write out all my information about this. Time equals 0 minus. That means I need to draw my circuit at time equals 0 minus. Two facts I need to know are about steady state and when time equals 0 minus, or, well, I should say and, time equals infinity. No, I should say or. Okay, time equals 0 minus or time equals infinity. Then the circuit is in steady state. This is important to memorize. And then another thing I need to memorize is that at steady state, we open capacitors and we short inductors. So I need to know both of those things. When time is 0 minus, the circuit is in steady state. And at steady state, we open our capacitor. So now let's draw our circuit at 0 minus with those things in mind. Here's the original circuit again. So at 0 minus, the switch has not gone to B yet. It is still at A because it's not 0 yet. It's almost 0, so it's still at A. And 0 minus means steady state. At steady state, we open the capacitor. It's important to write what we're solving for. We're finding the voltage across the capacitor, or same thing as where the capacitor was. So voltage across where the capacitor was at 0 minus, meaning we drew the circuit at 0 minus. So this is the quantity we're solving for. This is dead wire, so I'm left with the rest here. I'm going to circle my nodes. Be careful about combining resistors at this stage. I prefer to leave things as is if possible. This is VC, 0 minus. I'm just going to call this 60 volts. If you want to label this as a variable, you're welcome to. And this is ground. And I'm going to write my equation at this node. VC minus 60 over 6 plus VC over 3. This way, and then there's 0 current going through here because it's an open circuit. So set this equal to 0. Clear my fractions by multiplying the equation by 6. Combine like terms, move the 60 over. VC is equal to 20. So specifically, VC at 0 minus is equal to 20 volts. I can't find that constant A right now, but again, this is what I need to find the constant A later. So the second quantity is done. I'm going to come over here now. Now I need to find VC steady state. Which again is the voltage across the capacitor at time infinity. So I need to draw circuit at time equals infinity. Remember, at infinity, the circuit is in steady state, which means what? It means we open the capacitor. So let me draw this again. Consider where your switch will be. At infinity, infinity is greater than 0. So if I go back to my number line, this is infinity, obviously, at the very end. And so infinity is greater than 0. So we know that the switch moves to B at 0. So any time past 0 would mean the switch is still at B. Open capacitor. And we're finding the voltage across the capacitor at infinity. This is our dead wire. I'm going to circle my nodes again. That's 24 volts. This is VC. Reference node or ground. I'm going to write my equation at that node. Minus 24 over 6 ohms plus VC over 3. So I went this way, then I went this way. 0 current through here again because of open circuit. Set equal to 0. Clear the fraction. Combine like terms. VC at infinity equals 8 volts. Moving over here, I'm going to write out my original formula again. And now it's time to plug stuff in. So I start by plugging in tau and VC steady state. Tau was 4. So T over 4. VC steady state was 8. Now what I need to do is plug in that initial condition I found. So VC of 0 minus is equal to 20 volts. This equation is for time greater than 0. And the initial condition I found was for 0 minus, but recall that VC, oh, hopefully this focuses. VC 0 minus is equal to VC of 0 plus. It's just that we couldn't solve for this, again because of some theory, but we can solve for this. But they essentially equal the same thing. So voltage at steady state was 8, tau was 4, and then now I'm going to plug in my initial condition of VC of 0 minus equals VC 0 plus equals 20. So I'm going to plug that in. VC 0 plus equals AE to the negative 0. Remember, we're plugging in 0. Plus 8. And this equals 20. Equals A, e to the 0 is 1. Solve for A. A equals 12. Now I can finish up this expression. VC of t equals 12 e to the negative t over 4 plus 8. And this is voltage across the capacitor for time greater than 0. Now, we found voltage across the capacitor. Remember I said at the beginning of the video, no matter what the problem statement asked for, the first thing we need to do is find voltage across the capacitor. So we've done that, but what is the problem actually asking? It's asking for I of t, for all t greater than 0. Here, this is what they've designated as I. So I, we see, is the current going through the capacitor. Well, we need to know what the formula is for current going through a capacitor. And it is, so IC equals the capacitance of the capacitor times the derivative of the voltage across the capacitor. Maybe now you can see why we couldn't directly find this first. We needed to find voltage first across the capacitor. So to find that I need to take the derivative of my voltage across the capacitor expression. Okay, that's better. So let me take the derivative. Okay, let me check. If I integrated this, I would get e to the negative 2 over 4 times negative 3 divided by negative 1/4, which would be positive 12. So yes, that looks good. Okay. So IC of t equals the capacitance times negative 3 e to the negative t over 4. And that equals, remember capacitance was 2 farads. Equals negative 6 e to the negative t over 4. All right, so that is our final answer. This is current through the capacitor at time greater than 0. Hope this helped. Comment below if you have any questions, and let me know if there's any other problems you need help on.